Namaskar everybody and welcome to SDIT online classes. I am Dr. P.S. Kaushik. It is lecture number 37 on the subject changing mechanics and I will be taking the subject topic volumetric stress, volumetric strain and bulk modulus. Load. Load is defined as an external force acting upon a machine part. Following are the four types of load from the subject point of view, that is dead or steady load, live or variable load, suddenly applied or shock load, and impact load. Dead or steady load. A load is said to be dead or steady if it does not change it in its magnitude or direction or both in when with time. Live or variable load. A load is said to be live or variable when it changes continuously. Similarly, suddenly applied load or shock load, if load is applied completely in one go. Impact load, when the load is placed from suddenly from some specified height or with some velocity, then we say that this is a impact load. Volumetric strain, when a body is subjected to a system of forces, it undergoes some changes in its dimensions. In other words, the volume of the body is changed. The ratio of change in volume to original volume is known as volumetric strain. Mathematically, volumetric strain epsilon V is delta V upon V. That is epsilon V equal to delta V upon V, where delta V is the change in volume and V is the original volume. The volumetric strain of a rectangular body subjected to an initial force is given by epsilon V equal to delta V upon V equal to epsilon into 1 minus 2 upon m, where epsilon is the linear strain. Similarly, volumetric strain of a rectangular body submerged subjected to three mutually perpendicular forces is given by epsilon V equal to epsilon x, epsilon y plus epsilon z, where epsilon x, epsilon y and epsilon z are the strains in the directions x, y and z respectively. Bulk modulus, when a body is subjected to three mutually perpendicular stresses of equal intensity, then the ratio of the direct stresses to the corresponding volumetric strain is known as bulk modulus, or it is usually denoted by K, and mathematically bulk modulus equal to K equal to direct stress upon volumetric strain, or sigma upon delta V upon V. The relation between bulk modulus and Young's modulus. Young modulus is modulus of elasticity. This is the bulk modulus K and Young modulus E are related by the following relations. K equal to m E upon 2 in bracket m minus 2. Again one more relation, E upon 3 into 1 minus 2 mu. relation between Young's modulus and modulus of rigidity. Young's modulus of rigidity, Young's modulus E and modulus of rigidity G are related by the following relation. This is the relation G equal to ME upon 2 plus M equal to M upon 1 plus mu. During the online regular classes, I will be drawing this relation, the relation between E, G and C. Here is one example. A mild steel rod subjected to a tensile load of 50 kN. If the stress in the rod is limited to 100 MPa, find the size of the rod when the cross section is 1 meter. The is number 1 circular, number 2 square, number 3 rectangular with the width 3 into thickness. Okay. When the rod is of circular section, then D is given, let D the diameter, then area is given at pi by 4 D square here, which comes out to 0.7854 D square. So putting the value of, this is the force, this is the stress and area in terms of its diameter. On calculation, you find that D equal to 25.23 mm. Similarly, when the rod is of square section, then let the x is the arm of the rod, then area is equal to x into x, that is x square here. We know again that load P is 50 into 23 equal to sigma T into A. Sigma is 100, so 100 into x square it comes out to be, which gives you x square is equal to this much. On calculation, x comes out to be 22.4 mm. Similarly, size of the rod when it is rectangular with B equal to 3T. It is given there, so area becomes 3T square. On load, when formula is applied, 50,000 equal to 100 into 3T square, that is 300T square. On calculation, T comes out to 12.9 mm and B equal to 3T equal to 38.7 mm. This problem was really simple. One more problem. Again, a steel bar 2.4 meter long and 30 mm square is elongated by a load of 500 kilonewton. If Poisson's ratio is 0.25, find the increase in volume. Take E equal to 0.2 into 10 to the power 6 Newton per millimeter square. Again, these are the data. L is equal to 400 mm, A 900 square meter millimeter, P is a 500 kilonewton, this is 500 into 10 to the power 3 Newton. 1 upon M 0.25, E equal to 0.2 10 to the power 6 Newton per millimeter square. Here again delta V, increase in volume. We know that the volume of the rod V equal to area into length into, okay, that is 900 2400, which comes out to be this much, 2160 into 10 to the power 3 millimeter cube. Young's modulus E, stress upon strain. Stress is P upon A, strain is epsilon. So epsilon is equal to P upon A, which comes out to be 2.8 into 10 to the power minus 3. We know that the volumetric strain delta V upon V equal to epsilon into 1 minus 2m. On putting these value, volumetric strain comes out to 1.4 10 to the power 3. So delta V upon V is this much. hence delta V equal to V into 1.4 by minus 3, which comes out to be 3024 millimeter cube. Thanks for watching this video lecture. The references were machine design by R.S. Khurmi, engineering mechanics by Dr. D.S. Kumar.